Here we're basically doing one iteration of hierarchical clustering, and we're having a single linkage distance, and it does not matter whether it's Manhattan distance or Euclidean distance. Single linkage just means if you have two clusters, say A and B, the distance between the two clusters, you just find the distance between all possible pairs of points in A and B. There are many, so you find the smallest one, and you call that distance the distance between the cluster. So this is the single linkage one. And the opposite one is called complete linkage. So complete linkage. And it's basically find all pairs, find the longest one. So that distance will be the complete linkage distance. Mm, so here in this one, we're using single linkage. And the first step for any kind of clustering is find the clusters with the smallest distance so far and combine them, merge them into a supercluster. So here, suppose you have A, B, and say maybe C and D and E like this. So C and D is the closest. So what we're going to do next is to merge this into a supercluster called CD cluster. And then we need to recompute the distance between this large combined cluster to the other ones. So the reason why I find this is because this number is the smallest number in the table. So you just compare all of the numbers, find the smallest one. This will be this distance will be the distance between two closest clusters, which is from C to D. And similarly, this number is the same. It's also from C to D since it's symmetric. The first step, merge CD, and the next step is generate the new table. So the new table will be like C, D, and E. So the zeros are the same. So the distance between the cluster itself is the same. And A and B didn't change, so the distance between A and B should be the same as well. So the first one we're going to calculate is the distance between A and the CD supercluster. And since we're using single linkage, again, we're finding the minimum distance among all possible ones. So in particular, this minimum distance between A and C, which is this 2013, is the minimum distance among all possible pairs. So this is the smallest between anything in A and anything in D. And this number 2054 is the minimum distance between any point in A and any point in D, which say is this number. So when we merge C and D, the most important thing is realizing we didn't create anything new. So technically, they should not be combined like this, so they should be something like this. But to make the drawing simpler, it looks like I'm creating new points, but we never create any new points. We're just merging C and D together. So that means among all pairs of distances in the set C and D with A, the smallest ones are either this one or this one, and it turns out this number 2013 is smaller, so we're going to use that one. Because again, it's single linkage. It's find the smallest one among all of them. So this is the smallest one among all points between A and C. This is the smallest one among all points between A and D. And combining A, C, and D, we did not get anything new. So the minimum overall is just the minimum between these two, which is that number. So if you get this idea, then the rest will be easy. So A and E remain the same, nothing changed. And B and CD is the same idea. B and C and B and D, just pick the smaller one. So it's 2, 6, 8, 7. So again, it's the minimum from B to C and B to D. So let me draw it down here. So C to D is a bit longer than B to D. So I'm going to just use this distance as the new distance. And continue. B to E is the same, nothing changed. So copy this number B to E and CD to E. So CD to E, C to E is this number, D to E is this number, and find the minimum again, just that. And then this matrix is symmetric, so you can fill in the other half.